Okay, so I'm going to show you how to do the QQ plot that we were doing in class manually on your calculator here. So your calculator actually makes QQ plots automatically, but I think it's important to see the process because it helps you get acquainted with the normal distribution and things like the inverse norm. So I want to go through it manually with this video and just go through the steps so you have a reference here that you can look at when you're doing the homework. So in the stat editor here, the list menu, the list editor, I've entered in the data set that we were using in class. Just remember, this is the density of the Earth. This is Henry Cavendish's famous experiment. And so that's been stored in L1. So the first step in the whole process is calculating some sample statistics, like the mean and standard deviation. So let's go ahead and calculate those and store those. So underneath the list menu in math, you can find some of the statistics that we need. So the mean, so we're going to pass L1 into that and then store it in, let's say, A. And then while we're at it, let's get the standard deviation, which is 7. L1, store that in, let's say, B. All right, one more thing we need. We're going to need the total number of observations in this data set here. And that is the dim function under the list ops. If you see number 3 there, that's dim. It stands for dimension. So the dimension of the list, the number of elements in the list, or in our case, the number of observations in the list. So same idea, we're going to pass in the list, and then we're going to store it. In this case, let's say C. Okay, so we have all of the sample statistics we need in order to generate a QQ plot. We just got to transform our data set a little bit. So remember what the idea of a QQ plot is, a quantile plot. You're taking the actual percentiles, or quantiles in this case. Remember, quantiles like a generalization of a percentile. You're taking the observed quantiles of your sample distribution and comparing them against the theoretical quantiles you should observe in a theoretical, perfectly normal distribution, population distribution. So the idea here is we need to go to our stat editor and we need to do a little bit of manipulation here. So what I'm going to do is into L2, I'm going to create a new list here, and this list is going to be the z-scores. So just remember how you calculate that. It's going to be each observation in L1 minus the mean of L1, which we have stored in alpha A, divided by the standard deviation, which we have stored in alpha B. So we execute that, and we now have a list of the z-scores. So remember, the z-score is the number of standard deviations away from the mean. So this gives us a standardized measure of a distribution. So the next step here, remember, we need to sort these, right? We got to order them, because then we can compare that against the theoretical quantile that we should observe. So in other words, what we're going to do is we're going to back out, and we're going to go to second list here. Excuse me, stat. I always get that mixed up. It seems like it should be under list, but it's under stat. If you go to sort A, that stands for sort ascending. So we're going to pass in the z-score list, which is L2, and execute it. And then remember, this operation is in place, so that means it sorts this list and then stores it back into the same list. So now we have a list of sorted z-scores. We're getting close to what we need. So we've ordered these observations here. Now we can generate the theoretical z-scores. So into the L3 list here, what I'm going to do is go into the formula bar, and then I'm going to bring up the sequence editor. And remember, that's under list ops and then sequence. And so this is, I guess, the crux of the matter is what we're going to put into here. So we need to take the inverse norm of the observed quantile. So maybe if I write it out, what we're going to do is we're going to say inverse norm, and then it's going to be x, so it's going to be our variable here. And then we're going to divide by the number of observations plus 1. So number of observations plus 1. Remember, we stored that in C. All right, and then remember we have to pass in the mean and the standard deviation into the inverse norm. So we're going to give it a mean of 0 and a standard deviation of 1 for the standard normal. And we're going to take that over x from 1 up to the number of observations, which we've stored in C in steps of 1. Now if we paste this in here, give it a second, we have now generated the theoretical quantiles, or the theoretical z-scores, excuse me. So these are the z-scores we should observe in a perfectly normal distribution. And these are the z-scores that we have observed. So if we create a scatter plot of these, with L2 being the x-axis and L3 being the y-axis, if we observe an approximately linear relationship, that is implying that the distribution that we're looking at is approximately normal. So let's go to stat plot and see what we see. We'll go turn on the first one, and the scatter plot is just the first option, and the x-list should be the actual versus the theoretical, which we've just created. So if we graph this, and let's just make sure we get everything. Okay, so notice we have a linear relationship. There's some slight departures from linearity, but it's linear enough that it's approximately normal. So this is how you generate a QQ plot by hand. And just to illustrate how you would do this automatically, so let's clear everything and turn off the stat plot. Off. Okay, so there's actually a way to make your calculator do exactly what we just did. So if you turn it back on, I guess I could have just done that, but the very last one, that is a QQ plot. So it'll change the arguments down here. The data list, that's going to be the L2, and we want the data axis to be X. It doesn't really matter. You're still looking for a line in either case, but so if we graph this, we should see basically the same graph. So that's how you make your calculator do it automatically. It's a little easier, right? You don't have to do a bunch of sequence editing. But remember what we're looking at here. We're looking at the actual observation versus its theoretical value. So because you want the actual to equal the theoretical, right, that would, like y equals x, that's a nice 45-degree angle line, which is what we should observe in this graph, which is approximately what we have. You got to be careful here a little bit with the scale. So notice on the left-hand side, it's extending a little bit further than on the right-hand side. That kind of suggests maybe a little bit of a skew. But again, this isn't, I guess what I'm trying to say is this is kind of a way of establishing things that are not normal. So what you're really looking for here is significant departures from linearity, because then that gives you evidence to suggest that the underlying distribution is not normal. Remember, the null assumption is always normality, and you're looking for evidence to contradict the null assumption, the null hypothesis. We'll get into the whole statistical inference in the later half of class, but so yeah, I made this video because we're going to be using this as we move into the chapter about correlation and linear regression. The QQ plot is a way of validating one of the assumptions that we bring with us into the linear regression model, which we'll talk about that in a few classes. But hopefully this video should help you do the homework. Let me know if you have any questions.